Hello again, Algebras, and welcome to your Chapter 1, Lesson 3, Day 2 notes video. First, I want to review what we talked about yesterday in Day 1. So yesterday in Day 1, we discussed how we use our properties of real numbers in conjunction with the properties of equality in order to isolate our variable, to get our variable alone and find out what each one of those one variables is worth. And so one of the things we look out for is if we have to distribute. So on number 1 of the review, if we look, we've got a 5 outside of parentheses with no operational symbol between the 5 and the front parenthesis. That indicates that multiplication is occurring and we have to distribute that 5 or give by multiplication. 5 times 3x, 8x, bring it down to the next line. 5 times negative 2, negative 10, bring it down to the next line, and we haven't dealt with the plus 8, the equals, or the 43, so each of those come down to the next line. If on the same side of the equal sign we have like terms, like we do with this negative 10 and positive 8, we combine them right off the bat. So 8x minus 2 equals 43. Now next, we would add that 2 to both sides of the equal sign, the inverse of a negative 2 being a positive 2. We're going across equal signs on that one. And so now we end up with 8x equals 45. Now you might already be saying to yourself, well, I need to divide both sides by 8, but this is not going to give me a integer. That's okay, it's giving me a real number answer. All right, so 8 divided by 8 cancels out to a 1x, which is, of course, my goal. Bring down your equal sign, and let's get that decimal answer for 45 divided by 8. Remember, fractions are division problems. Division is a fraction. We get 5.625 as our answer for x. It's a terminating decimal, so still in the realm of rational. We're A-okay with that. Let's look at number 2, where we have distributing going on in the right, and then we'll notice we end up actually having variables on both sides of the equal sign as well. So we've got distributing going first. 7 times x, 7x. 7 times negative 1, negative 7. And now what I'm just going to do is bring everything that I haven't dealt with yet down to the next line so I can have all that work showing. On the same side of the equal sign on the right, I've got 7x plus 1 more x. These are like terms. They add up to 8x minus 7. But we haven't dealt with anything here on the left yet, so we're just bringing it down to the next line. Now I want all my variables on one side of the equal sign, all my numbers on the opposite side of the equal sign. So separate sides. A lot of people like to default in having their x's on the left. Totally fine by me. So we can subtract those 8x's over to the other side to be with the 7x's. 7x minus 8x, negative 1x or negative x. The opposite would be to make sure that the numbers go to the right. So I'm going to add 10 where negative 10 and positive 10 cancel out to 0 over here. And then over here, when I add 10, negative 7 plus 10 is positive 3. Now what's the only number left in front of my x? A negative 1. And what's the inverse of multiplying by negative 1? Dividing both sides by negative 1. So you'll hear a couple bells go off as I'm doing this recording. But here, negative 1 divided by negative 1 cancels out to a positive 1x. And over here on this side of the equal sign, 3 divided by negative 1 is negative 3. So x equals negative 3 is my answer here. Now, notice in both of those instances, we didn't have any fractions occurring inside of our equations. We're going to address a little bit more of that today in class. So remember that fractions are simply division problems. Keep that in mind as we start. What we want to talk about today is a proportional relationship and start using those in solving equations. A proportion is when you have one fraction set equal to another fraction. And this is telling me in a proportion that 1/2 is the same as or equal to 2/4. And if we think about that, that's true. If you have a full circle and you divide it into 2 equal pieces, each of those pieces, that is 1/2, right? If you had a full circle that you divided into 4 equal pieces, 2 of those equal pieces is the same as having 1 of these equal pieces. That's a true relationship. Okay, we'll even do this so we can see that those are true. True relationship. That's what proportions are describing to us. But what happens when I throw a variable inside a proportion? Well, now I need to still be able to get that variable alone. And the thing about this is inverse operations are still going to be occurring in order to get that variable alone. However, one of the things that we have done to try and streamline our process is we call this cross multiplying, when what we do is multiply both sides of the equal sign by these denominators to do some canceling out. So you'll notice I'll still get the correct answer for this when I show you what cross multiplying looks like. Cross multiplying is take the denominator of the first fraction and multiply it by the numerator of the second fraction. So 2 times x is 2x. Notice there is no more fraction when I do that. The denominator of the second fraction now multiplies across the equal sign to the numerator of the first fraction. 4 times 1 is 4. Now I have a linear equation that needs to be solved. How do I have a relationship between the x and the 2? Well, currently it's multiplication. And what's the inverse operation to multiplying? Dividing by 2. So 2 divided by 2 cancels out to a 1x, which is what I want. 4 divided by 2 becomes a 2. And if I look back to the original problem where we saw that, we already knew that the answer we needed in this numerator was going to be 2. Let's try that on some more examples. It is more likely with these scenarios that we will get fraction and decimal answers for our variables. So let's zoom into number 3. Okay, x over 12 equals 7 over 15. I know I have a proportion because I have one fraction set equal to one fraction. So when I have that situation, I have a proportion and I am allowed to cross multiply. So 7 times 12, or 12 times 7, goes this direction. And we'll just use, so we can remind ourselves how to use our graphing calculator to do this, 7 times 12, giving us 84. So one of my lines here, one of my sides is 84. Bring down your equal sign. Now do that across this direction. 15 times x, 15x. And like I'd already said, this is something we need to get used to. When it comes to finding our answers in proportions, it's more likely that our answers for x will include fractions or decimals. So of course, to get x all by itself, we divide both sides by 15. 84 doesn't evenly divide by 15. But since 84 was the answer to the last thing that we did, we can now just press our division and 15. So we are dividing the previous answer by 15. 84 divided by 15 gives me x equals 5.6. So basically, how many twelfths are the same as having 7 15s? So 7 pieces out of 15 total. If you had 5.6 of these 12 pieces, you would have identical numbers of pieces. It's our way of kind of making this streamlined and understanding what these two fractions would mean if they were the same. Okay. Number 4. So this time, I'll still start with this denominator across to this numerator. Again, fraction equal fraction. So when you have one fraction set equal to another fraction, you can use cross multiplication. 21 times 15, so 21 times 15 gives me 315. Bring down your equal sign. And now it's this denominator by that numerator. So opposites across the equal sign. Notice I'm kind of showing that to make sure you're going the correct directions. And we can only use this when we have proportions. So 3x times 10 gives me 30x. Okay, look, once you've done that, there is no more fraction. So now we divide both sides by 30 to get our variable alone. So 30 divided by 30 cancels out to a 1x, which is what I want. And then 315 divided by 30, well, remember, 315 is the last answer we have right here, so you can just press your division and 30, and it takes the previous answer and divides it by 30. So now we've got 10.5, 10 and a half. X equals 10.5. Okay, so check those out. This is the only time I get to cross multiply is when I have one fraction set equal to another fraction. Only time I get to do that. Let's flip over and look at the next page. Now, what happens if there's 2 terms in a numerator or 2 terms in a denominator? So notice in these other examples, there were just single terms top and bottom. Okay, now this is still one fraction set equal to one fraction. This is still a proportion. This can still get cross multiplied. However, what's really happening in the cross multiplying is everything in this denominator multiplies by everything in this numerator. Right? So this is fine because these are single terms. And we do already know that 6 times x is 6x. However, this denominator has to multiply by everything in this numerator, which means this is really 5 times x plus 5. So I wrote that out so you can see that you need to make sure that 5 gets distributed. 5 times x, 5x, 5 times 5, plus 25. Okay, bring down your equal sign and your 6x that was over here on the left. Now we can put all our x's together on one side of the equal sign, leave our number where it is. So let's subtract that 5x from both sides. And luckily, that's actually going to give me 1x all by itself, right? 6x minus 5x gives me 1x. Bring down your equal sign. These had canceled out, so all that's left is my 25. I know that x is equal to 25. Let's try that again on number 6. So on number 6, start with your denominator of 4. It gets distributed throughout the other numerator. So both of these things get multiplied by 4. Let's write it out as 4 times x plus 2 so that we remember both of these things get multiplied by 4. 4 times x is 4x. 4 times 2 is plus 8. Bring down your equal sign. Now do that across this direction. 5 has to be multiplied by both the x and the minus 3. So smart to write out 5 times in parentheses x minus 3. The binomial, the thing with more than one term, gets put inside those parentheses, and this single term gets distributed. So 5 times x, 5x, 5 times 3, negative 15. Okay, I've got x's on both sides of the equal sign. I got numbers on both sides of the equal sign. So let's kind of try to get this moved along a little bit easier. What I do notice is I've got 5 x's and 4 x's. So if I were to subtract the 4x over here, I'm only left with 1. That's really smart. We only want 1x in the first place, so let's get that 1x. And now let's move the number over. So add that 15 to the other side. If all my variables are here, all my numbers go here. 8 plus 15 is 23. So x equals 23. 1x equals 23. I am going to pause, and I am going to have you try 7 and 8. So I'll keep this right here so you can see what we did on 5 and 6. I want you to pause this video, and I want you to make sure that you try these two, and then come back and we'll get those answers, and we'll see if there's anything else that you might want to be looking at. Okay? So let's pause this, and I'll see you in a sec. Okay, algebras, welcome back. How did we do? Follow along. Make sure you've got each line of work and you're showing all your steps. Make sure you're not missing out on distributing that single term throughout any multiple terms in either numerators or denominators. And that should get you to your final answers correctly. Please make sure you are trying 1-3 homework number 2. We will check that later and write down any questions you may have for me so I could answer those for you in person. All right, I will see you next time for the next one. Thanks so much. Have a great rest of your day.